If your testing requires your signal generator to do frequency sweeps, you're going to care about how fast it's able to switch between frequencies. The faster it switches, the faster your test time is going to be. So today we're going to measure the switch speed of this compact signal generator using our FieldFox. And for this setup, Kevin's here. Kevin, thanks for being here.
Yeah, thanks Daniel, glad to be here.
So tell me about the setup we have here.
Yeah, so what we have here is the compact signal generator, and what we've done here is we've set up the generator to sweep between two different frequencies, 980 megahertz and 1020 megahertz. So it's sweeping between those two frequencies and then outputting that sweep into the FieldFox over here.
So this is a lot happening on the FieldFox. Can you talk me through how you set this up?
Sure. So what we've got on the FieldFox is showing real-time spectrum analysis in spectrogram mode. So in this mode, we are in real time capturing the frequency changes over time. This axis down here represents frequency. This axis up here represents time, and then power is color graded. You can see it starting on this left side of the screen at 980 megahertz, and then it is switching over to 1020 megahertz over here.
I see a couple things initially. I see this kind of streaky red band across. I assume is that also corresponding to that kind of flickering between the frequencies? What's happening there?
Yeah, so what happens is as you see the bursting signal going up and down across the screen, the signal is changing from 980 megahertz over to 1020 megahertz, and depending on the processing speed of the FieldFox, it's showing that transition. So you'll see on the screen, you'll see sometimes the signal will be over at 980 megahertz, other times it will be at 1020 megahertz, other times it'll be transitioning between those two, and you'll see those signals at various times flashing up on the screen.
So this is a pretty complex measurement because we're measuring frequency, we're measuring power, and we're also measuring time, so kind of a three-axis measurement. Can we capture this and measure the time it takes to get from 980 to 1020?
Yeah, we can, and that's actually exactly what we've set up here, is so that we can use this FieldFox using that mode that I talked about, real-time spectrum analysis, spectrogram mode, to measure exactly how long it takes the generator to switch between 980 megahertz and switch over to 1020 megahertz. So to do that, I want to be able to look through the time record of this acquisition, so I'm going to go over here to the marker button, and I'm going to enable time markers. With this single acquisition, I can actually move through time and show how the 980 megahertz signal is moving over to the 1020 megahertz signal. And I can use this scroll wheel to go through time and show that transition. So if you look at it now, you see the signals over at the 980 megahertz point. And as I start to turn the wheel here, you'll see that the signal starts to transition. It's transitioning, and it's now transitioned all the way over to the 1020 megahertz frequency point. And if you look closely here, you'll see that the delta time.
So it took just under 31 microseconds to change frequencies. Is that typical for an instrument like this, or what's kind of normal for a signal generator?
No, it's not. For a typical analog generator like this that you would just use as a general purpose lab instrument, most of those generators, including many of them from Keysight, would typically be able to switch frequencies on the order of 10 milliseconds, single-digit milliseconds, maybe at best 800 microseconds. But you can see with this new compact generator, we can switch much, much faster than that.
And a lot of this, I'm sure, comes from just designed intent, where we knew coming into this, it has to be able to switch quickly. What sort of applications are driving that requirement?
Yeah, that's a great question. So if you're working in antenna tests, for example, you may have to test thousands of frequency points. And if I have to test thousands of frequency points, time is money, so I want to do that frequency sweep as quickly as possible. Now, if I can use something to do that frequency sweep an order of magnitude faster than I used to be able to do it, that means I complete my test that much faster. So that's going to be of interest to me as an engineer. Or if I'm doing filter testing and I'm sweeping through a bunch of frequency points through my filter, if I can do it that much more quickly, that means I finish my test more quickly. Again, these days time is money, so that's where this fast frequency switching can come into play. Another application, Daniel, is for radar test. Radars move quite quickly, and if we want to emulate a simple radar signal with something like this, we need it to be able to switch frequencies very quickly, which that can do.
And we can do CW signals, we can do pulse chirps and that sort of thing on this as well?
Correct, yeah. These compact generators have a variety of modulation capabilities built into them. Analog modulation, like amplitude modulation, frequency modulation, phase modulation, pulse modulation, as well as a built-in chirp function in the instrument standard.
So this is a pretty great signal generator to have in your device. If you just need to plop something down, grab it off the shelf, and make a quick measurement, this is much nicer than lugging a big high-end one around.
Yeah, correct, right. This little guy weighs about 8 to 9 pounds. I've heard from many engineers where they would much prefer moving an 8 to 9 pound box around the lab than a 80-pound box around the lab, right? So it really makes that nice. But even though it is compact and small, it still provides a lot of capability as we've shown here.
So when I think time is money, my brain goes to manufacturing, where people are building an ATE system, and the faster the test, the more they can get through, the more money that factory is going to make that day. Is there a rack mount kit? Is there a thinner version of this? What does that look like?
Yeah, great question. So there are rack mount kits for these desktop versions of this instrument, but often, as you said, people are building ATE racks, and they want to make those test racks for production as small as possible. So we actually have a 1U version of this generator, 1U high, 19-inch rack width, very small, but still provides all the same capability that you have in this desktop version to support our production test customers.
What frequency ranges are we looking at for the 1U?
All the way up to 26 gigahertz.
Okay, pretty fast.
Yep, in a very, very small package.
So a small but mighty signal generator, both for the benchtop or the 1U version for a rack mount system. Great little tool to have, much better than a big thing you got to lug around.
Yep, very capable, pure, good spectral purity, good signal quality, all the standard modulation capabilities you'd expect in an analog generator, and small, 8 to 9 pounds, and cost effective as well.
Awesome, thanks Kevin.
Yep, thank you.
Learn more at keysight.com/find/signal generators.